Uh, Good evening, everyone. I hope I'm audible. Please let me know if that's not the case. So
Yes,
today,
sir, you're audible.
thank you. So today, meeting for the coding session, and we are now moving on to some of the things that are there in the third sector of our uh, course objective, effects and animations and mechanics. So we have learned some basic mechanics till now, uh, like initially when we made the color runner game or the rollerball game. There, the game mechanics were fairly simple. So now, when we are creating a shooter game, the gameplay mechanics have changed a bit. So now we are learning the mechanics of a shooter game, which includes a lot of different systems like raycasting, nav mesh, which we are on right now, uh, and a lot of other things which we'll see in the future. We've looked at effects, some of the effects like particle effects, and we have now looked at different ways of controlling audio at different times, and that is one of the effects that we have been through. We have not done animations yet, which we'll start today, hopefully. So next, this is where we are right now. So in the last session, we covered weapon effects. We completed that. We had a little bit of a detour and we looked at Pro Builder, which is a tool in Unity to basically create meshes and all the tools that all the possible things that are available for 3D, but like at a prototype stage. So we did that in the last session. And then we started with Navmesh, where we started breaking very basic Navmeshes and saw how what it means. Now we'll actually see a bit more of Navmesh where we left off. We'll continue that, and then we'll implement that the concept of Navmesh and how that works in the game that we are building right now, this shooter game. Then we'll add using Navmesh and animations, we'll create an enemy AI, and that will be the next step. And then once we have created an enemy AI, we'll create player damage. So right now, what we have done is the player can shoot the enemy, but the enemy cannot do anything back to the player. So that is what we'll add next. And then from there, we'll move on. Like after that, then it depends what you want to do next. So I think we are down to like I think this is in chronological order. So 15 sessions. So we are almost halfway through. So we have done a lot of things. So maybe next 3, 4 more sessions we can give to this a few more concepts that are left in Unity, uh, which we have covered mostly, but maybe a few concepts are left. We have animations we can look in more detail. So like right now, what we'll do is we'll look at some part of animations, then we can look at more details like in animations. Um, we'll come back to UI a bit, where how to put score in UI and all those things we can look at, which we did a bit before as well. So that's a bit of repetition which is required. And then after that, I think we can move on to XR, where we can, depending upon uh, like uh, the conditions, we can either start with augmented reality and or virtual reality. I will discuss this with one of your coordinators separately, like the availability of VR headsets at your place. I'll also try to arrange a few physical sessions. So I'll try to come at least for 1 or 2 sessions for specifically for VR because that would be better to see in uh, like see there in physical classroom. Uh, so we'll plan that, and then I also wanted to cover some. If you remember, initially we talked about how Unity is being used for computer vision, like how Unity is being used in artificial intelligence research. So there were two things that we wanted to discuss that I wanted to discuss. One was the synthetic data generation, for computer vision specifically, and then second was reinforcement learning. So there are some tools in Unity that so we can devote 1 or 2 sessions to that, and then one session for Spark AR, which is a tool from Facebook, which is a separate tool for creating filters and stuff, games, and whatever you see on Instagram. Those are created in Spark AR. So either if time permits, we'll do all those bonus stuff as well. If not, then either the interested people can reach out to me or I'll share resources depending upon what you want to do. So for today's session, let's move to Unity then. So this is where we left last time. Going away. You're still able to see my screen, right? Just stop sharing one side. Yeah. Can you guys see the screen?
Yes, sir.
Okay, cool. So yeah, so this is where we left off last time. Just a quick recap. We built in the last session. We built like this was something that we built quickly, but I think yeah. So this is what we had built, and this is what we'll check on the nav mesh. And this was a test. Like this is I think what we'll actually use because this helps visualize more things. So this is what we did last time. We baked a nav mesh. So this was our nav mesh that we had baked. We wrote a code for the agent to basically follow the reach the target location, and that code is available here. So it was very straightforward. There we just defined an agent, we defined a navmesh agent, we defined a target, and using navmesh agent, we just did set destination, and that was the position of the uh, target. So what this came out to be look like was something like this is where if I move the target around, the player will try to find the shortest path through that. So this much we did in the last session. So now for next, what I want to do is I'll turn off the base example and I'll show this environment first on the environment which we built in the last session using Pro Builder. This is what we had built. So basically what we can do again now is if we go to navmesh, because this navmesh is a baked navmesh, there's not updating in real time, which also is a possibility and you can explore. If I remember, like when I did it the first time, that time this like real-time navmesh was available as a separate additional feature in a GitHub in navmesh GitHub. I'm not sure if they have integrated in Unity till now or not, but I don't think that they have. So, but that is also that can be explored. So if I build the nav mesh for this, all I need to do is just click on bake, and I'll have a nav mesh build for this. And similarly, if I look at my agent, so my agent is a bit too small for this, but if I have to move him around, it'll still work as expected. Now the thing is that I can uh, try and place it above ground as well so that the player tries to go up the stairs and all those things. So but now what we really want to see is what are these conditions that are here, and how do these affect the nav mesh that is being baked. Because if you see, we are coming to this page and we are baking the nav mesh based on these conditions. So what are these conditions and how are they helping us build a better nav mesh, or uh, what actually is it doing for us? So to do that, I will go back to the environment that I had. So I'll turn off the environment that we made together. I'll turn on the environment that I had, sorry, previously I had this one, and let me quickly just color it using the materials that we made. So ground is black and objects are yellow. Hello.
Yes, sir.
Uh, did I go off? Where did it go off? Were you able to see this all?
Yes, sir.
Okay, so I'll just continue from here only. Thank you. So basically, this is the environment that we'll test a few things on. And let's bring our agent on level with the environment. Let's bring the target on level with the environment. It. So now what we want to do is if I go to navmesh here, so again we have the old navmesh baked and again baking it based on the similar uh, conditions. So if you see what we want to see now the different things that are here. So if you see there are a few mistakes in this nav mesh that you can clearly see this. Uh, there is an off mesh link that this is not linked properly. But these small things can be fixed by changing the shape and size of these things. What we want to see is how what are the options here? So the very first option is the agent radius. What happens if I increase or decrease this? So this basically defines how far away from the from obstacles or from objects in the environment can the player travel. So like this is why this specific area has been defined. Like let's say if I keep it at 2 and then try to bake it, you see that this is not walkable anymore. A lot of area is not walkable anymore. Let me make it 1. So now you can see that this area is walkable, this area is walkable, depending upon how you scale your environment. This radius will basically define how much distance should it keep from the obstacles or from the objects that are there in the environment. So let me go back to the default. Wait. And the next thing is height. So for height, why do we need height? Is basically for something like this. So if I had a height feature, like let's say I make it 5 and then bake, then this is not walkable anymore. So this height here is more than 5. That's why this is not walkable anymore. So this is, I hope this is clear, that based on the conditions that we create here is how our nav mesh is being built. So our agent radius defines how far can the agent walk from an obstacle or an object in the scene, and the height defines how much height can the what is the height of the agent, and if there's a like a doorway or something which is basically or an arch which is lower than the height of the agent, then the agent should not be able to walk through that path, or even a tunnel. So the agent should not be able to walk through that way. Setting that back to normal. Next we have max slope. So slope is basically this thing. Right now it's on 45. So you can see both these slopes, these two slopes are there, which are accessible. This one slope is this one, and the other slope is this one. So if you see this one is a bit more steep. So if I let's say make it 60, am I able to get this one? I'm not able to get this one. When I do 90, 90 won't matter because this threshold is 60 for the slope. So this slope, it's a bit too much. But like if I bring it down to 25 or something, so you see this slope is gone, but this slope is still there. So this is what defines the slope. What is the slope that the player can actually uh, travel or actually walk on? Then we have step height. Step height defines the what is the maximum height that a player can step on. So, like, let's say if I make this 0, then the stairs and the slope and everything will be inaccessible because that is above the ground a bit. So that's why it was originally 0.3 or something. But let's say if I make it 2 or something, then it's more accessible. A lot more areas become accessible if you see. So that's the step height. Then there are certain things which are off mesh links. So off mesh links basically means that this is one mesh, this is the other mesh, and how can we link these two meshes? So there are two types of off mesh links that are available. One is drop height and one is jump distance. So drop height is basically, let's say I define this as 5 and then break. So drop height is if a player is here, will he directly jump off? So let's test it out. And to do that, what I'll do is I'll first place the target target over here somewhere. Okay, and then let's play. And the player will try to go up here and try to reach the player target. And now if I bring the target down, the player can jump from there directly and reach the target. But in case I didn't have the off mesh links, let's go back and see what happens if I don't have this. So in this case, again, I'll play and the player, I think it's not trying able to reach because of the height, or I think, oh, it's not properly placed. So now when I bring it back down, the player will have to go the complete other way and then come here. So this is the difference when I create a off mesh link. So that was for the drop height. It's basically dropping from a height. And then there's jump distance. So jump distance can be defined between these two planes. So let's say I keep a jump distance of 10. And this is not defined, but here you see a jump link has been defined. So if I bring the target here somewhere, let's see if this works. So first, let's say it's here. Which is that position, and then I move it here. Oh, so it has to be in an instant because it's current updating regularly. So you won't be able to test it. But this is basically a player would jump this distance if it was allowed. Like this is creating that distance. So then you can keep that to 0, bake. Next, there are a few advanced settings. So one, we have manual voxel size. So this voxel size is basically voxels per agent radius, which basically defines how much better defined should each radius, like each point in the nav mesh be, and lower this value, higher the definition of the uh, nav mesh, and higher the value, lower the definition, but lower the value, higher the definition, but also higher the bake time. Like right now, you see that whenever we change a value, the bake time is instant. But if I change the value to a very low value and then try to break it, like right now it's 0.16. So what if I keep it 0.000001 and then try to bake it? It'll take a very long time. But if I make it 1, it's even faster, and but the nav mesh would not be that well defined. So you can try that out. And then minimum region area is basically the area that a minimum area that a nav mesh region can be. So like this thing probably uh, this thing, this area is not a minimum. Like I have defined here, it's defined as 2. So let's try 0.1 and then bake. It's working. But this is what it means, that what is the minimum area that, like there here it might be some other condition as well, that is because of agent radius and agent height, some other condition might also be in play. But this is generally what minimum region area would mean, that the minimum area that a nav mesh can be. Like, so if some other condition would be fitting here, then this area could be accessible. I think this is not accessible because of height or maybe radius or something. So this to, let's go back, and then height mesh is basically, if we create a height mesh, this basically helps in creating steps and stuff. So this will right now we are not able to do it because the this was already not baked properly. But if we create a height mesh, this will basically create a specific like a proper step by step. And right now when the player is moving, like if you see the player is moving smoothly above these stairs, like it's gliding and not actually it is actually stepping. So maybe we are able to build the height map. It's not just visible. Let's see the difference. So yeah, there is a difference, maybe something wrong with the visualization, but I hope you see the difference. So when we, like right now, height mesh is not there and we have baked. So when this happens, is basically the agent, it glides over the stairs. But when we have a height map and then we bake, the agent will take that these stairs like the stairs, and these are steps that the agent is taking. So this is about the height map. So what other things do we have here? We have areas which we can define as walkable or not walkable, or jumpable or not jumpable. So there are a lot of areas that we can define, and there are different ways of defining these areas. Uh, Basically, there's a volume that you can define, or a different plane can be a different area. Those things can be done. So basically, let's say if I come here and select this specific mesh and I make this jump, and then I go to bake, and then I bake. So this, you see the area of this mesh changed. So I can similarly, I think there's not properly, but I think there's volume that we can place. Hmm, nav mesh obstacle. Nav mesh. I forgot what that was, but there's a volume that you can create, and then the area can be defined there as well. So you can define other areas, and basically you can use these values for certain things that you want. Um, and you can try to test it out and see how this works. So basically, let's say in some area, the if it's fire, like there's a fire burning, then this you can define a value of how player health should be different there, or something like that, right? Like not this value, but in your script, you can define those values by checking which area the player is in. Then we have agents. So this is where we are actually defining the different types of agents. So if I go here in my agent that we already have created, if you see our first thing that we have here is the agent type. And what we only have one type right now because we haven't created any other agent types. So like right now we are creating zombies, we can create a zombie agent, but zombie is a humanoid, so that is not required. But let's say I'm creating a car or a robot or something else, then I can create those things and I can define these things for that specific agent. And these settings will directly load here when I want to bake those things for that specific agent. When I want to bake the scene for a specific agent, I can use these settings. So this is about it uh, for the nav mesh. Now we can go back to our original scene, which was the main scene. And here we can, what we want to continue doing is basically build. We have this player, we have the enemy. Now we want to start creating the enemy movement. And like right now, what we have here is this thing. Let's just run enter. It's too loud. This is what we have right now. We shoot the enemy 10 times and then it goes away. Currently 11 times. But yeah, so this is where we are. And now what we want to do is make the enemy move, make the enemy attack the players. So for that, the very first step for us would be to generate a nav mesh here in this area. So all we need to do is go to bake, and with the defined settings that we already have, just click on bake. So for our enemy, and basically you can see that our nav mesh is baked. We'll just keep the default values for now. Later we can try and add some non-walkable areas or some areas where the enemy is faster, things like that we can do. So like this is a zombie, so generally the zombies would move slower, but we can have some activated zones where the enemy moves faster. So these are things that you could try to do on your own as well. And this is what sets you apart. So like what we are learning right now, this is something that everyone will learn and everyone will make and everyone will show in their portfolio. But what you need to actually do and what you need to actually show is something additional. So that's what you can try and do. So just one more thing is that when we build the bake the nav mesh, there's a nav mesh created in our folders as well. So now inside for the main scene, there's a folder that's created called as main scene. Inside that folder, there's a nav mesh. And similarly for nav test scene, there was a folder that was created because this is an asset which is pre-baked. It is not created at runtime. This can be saved as a separate asset and can be loaded during runtime before uh, the runtime actually starts. So we can close navigation now. We don't need it. We don't need to even visualize it. We have created a default nav mesh. And one thing that I just want to do is create a folder here for third-party assets and just tidy up our complete structure. Just close this one now so that and okay. This also pro builder data. This we basically used for some of those things. We want materials out here. This thing, this thing, this thing, and this thing. Now we can go in third-party assets. So this is generally from time to time we should also do this. Is basically try to keep your structure intact, and because we have changed paths and stuff, you can just try if everything is working as it should. So yeah, so everything is working properly. We have a few prefabs that we do have. We should have also created prefabs for the things that are these uh, where are those things? Oh yeah, the muzzle flash and the gun maybe should have been kept as a separate prefab if you wanted to use it somewhere. The muzzle flash could have been our own prefab. Like right now if we open this prefab, this is a prefab that we imported. So we can generally it's best to create your own prefab for those things. But right now we have already I don't want to mess anything up, so that's why I use what we already have. So moving on, next thing what we want to do is we want to work on the enemy zombie. So I'll bring it down here, and then the first thing we want to do is add an mesh agent, and we can place it above the health script. For that, it will require opening the prefab. We don't want to do that. We want to apply to the prefab. And next, we also want to create a new script known as enemy AI, which we'll do here first. And script open. So this thing is not required anymore. We can close this one. But we'll use that same concept here. If you remember, we use the concept of a okay, concept of the target. So we'll use that same thing. So just as a again going back one step, when we add the so if you see right now what it has is a virtual collider, and this is how it's looking. But when we add a nav mesh agent, there's a separate component that you see around the agent. So this is what the height and all those things that were defined there for the agent. This is what it is. So now we can visualize those things as well. So now what I want to do is attach this enemy AI script that we have created on this and then start working on this. So the very first thing, if you remember, is we have to import and include the Unity Engine AI, and then first thing we'll do is create a nav mesh agent, and we can call it agent. Then we'll create a target for our enemy, and that target will be a player, but we can get that in the start itself. We'll write that in code because we will eventually create multiple enemies and we'll instantiate those enemies. So that's why these things need to be written in code. We can't drag and drop these things separately for each enemy. And then target can be game object dot find. I think you know all these things by now, at least what get component does and what game find game object and what objects with tag does. So we want to find an object that has the tag player, and we want to take the transform from that object. But if I go back here, I don't really have a tag attached to my player. So I'll do that and override it as well. So yeah, so this is what we get. We created a script where basically we have defined a start, and now to basically start doing the animations, uh, start doing the movement, I want to basically do the movement along with the animations. So we'll first create animations and learn a bit about animations very quickly because we want to focus on this. So that's why animations right now are a small part of that. So there are two types of basically animations things that you can try have here. One are animation clips and one is an animation controller. So animation controller is basically a controller which controls the let's think of it as a manager which controls the logic of all the animations that a game object is supposed to play. So what we'll do is we'll create a new animator. So if you see here, there's an animator controller and an animation. So what we want to create is an animator controller, and animations we already have from the asset package. And we'll name this zombie anim controller. You can name this whatever. And when I open this, this is what opens up. It has few things, and to move around in this is basically you have to click on Alt. So I'm pressing Alt right now, and then I'm clicking my left mouse button. Let me see if I can open this and it works. Next time I'll try to set it up properly. Anyway, so it's not working. So anyway, so I'm pressing Alt and left key to move around here. So if you see, I have an entry state, I have any state, and then I'll add some animations in here. So I can bring this here. I don't want to use the exit state. So entry state would mean basically this is where the entry happens. Any state is wherever the whatever the animation is currently running uh, is any state. And I can transition from here to something else. So basically what this is a flow diagram of what happens. So let's bring in a few animations, which we move to third-party assets and inside zombie and inside this animations folder. So how do I check what animations I want? So if I go here, I can basically see the animations. I can play the animations and check here. Like right now you see a generic Unity thingy here, but I can add a model here to make it to see what it actually will look like. So this is one of the animations that I need. It's going back to folder. So this is attack, and then falling back is basically dying and falling back. So this is also what I'll take. There's idle, so just standing there, which also I will take. There's run. So run, basically you see this is running forward, and then there's a run in place. So the run in place is what we'll not take run for now. We'll take walk, and for that also we'll take walk. So there are two types of walk. This is one walk, and the other is where the hands are down. So we'll take the first one, but or not the first one, the second one. So walk in place, uh, this one, and then this is an animator controller that is already created in the example scene, if you remember. So these are some of the animations that we have, and these are the rigs for these animations, but we'll just use these and go back to where did we create it. This is our animator controller and animations. So I need attack, I need falling back, which is dying, and then I need walk in place, which was this one. And is there anything else? I think I'll take idle as well. So these are some of the animations that we work with. Great. So now what do we want to do next is what we'll set up some conditions, some transitions and some conditions for these animations. So the first thing what I want to do is uh, define which state uh, should the very first state be, like from entry, where should the player actually go to. So from entry, I think we make the transition to idle, actually set state machine default state would be idle. So from entry, the first state that the player would, that the agent, that the zombie would go to is idle. And from idle, it can go to walk in place. From walk in place, it can come back to idle. From idle, it can go to attack. And from attack, it can come back to idle, similarly between them as well. And then from any state, it can fall back, basically die. So this is how we have set up our uh, transitions in our or our state machine in a sense of animations, and this is how we'll also set up the AI. It can walk, it can attack, and or it can die. So these are the three things. We can also add run if we want. So like right now, what we'll use is a distance from the player. So we can have two sets of distances. So for one distance, it is running. For one distance, it is walking. But right now, the place is very small inside the environment. So we'll start with one at least, and then let's see where we are lead. So now what I want is basically some condition should happen for me. Like I said, the distance for me to basically go from this condition to this condition. So now how do I do that? Is basically I can have this list of conditions and I can add a condition here. But to add a condition here, I need some parameter and there are no parameters right now. So these parameters are basically what defines transitions between two states. And there are, sorry, I added a layer. So there are four types of parameters that are there: float, int, bool, and trigger. So float parameters can be used when we want to like in this case also, like if you want to define what speed the walk should be of, we can use the float variable. We can pass that variable from script to this animator controller, and that would help in walking or running. Similarly, for integer, some specific value can be defined and that value can be used here. But that is not what we want to do. We'll use bools and triggers. So we'll use a bool and we'll call this is walking. We'll create another bool and call it is attacking. And we'll use a trigger and call it is dead. So what we'll do is now set up the parameters for the transitions. So from idle to walk, we'll use is walking, and if is walking is true, and we'll remove this as exit time. So this basically immediately will change the transition. And from walk to idle, uh, it will be is walking is false. From walk to zombie attack, condition would be is attacking true. From zombie attack to zombie walk, it will be is attacking is false. And or it can also be is walking true. So these both conditions can be there. And then from idle to attack, this one and this also, I forgot to remove the exit time. So we'll remove the exit time of all the conditions. Similarly, from idle to attack, we have is attacking is true. From idle to attack, is attacking is false. And just checking again, zombie to attack would be is attacking is true and is walking is false. Attack to zombie would be is attacking is false and is walking is true. So this is our condition for these things. And then we have a trigger here, which we'll use for is dead. So if is dead trigger is basically a single value. So if this is trigger, this one turns on, then basically this animation will play. So now let's go back to our scene and let's go back to our enemy. And here where do we actually attach this enemy, the controller that we have created? So we have an animator. Uh, this animator thing is there. Animator game object is there. Animator is there, which we can attach it to. So we attach this animator here, and we also need to attach an avatar. So this avatar is available inside the FBX file that the zombie would have. So let me see and go here, animations FBX. So we use the zombie one. So this is the avatar that is there, zombie one avatar, but it is directly available here as well. Like I can just search here and zombie one avatar is available. So now I have this, and now we can write some script to basically access those things. So let's go back to our enemy AI script. And inside the script, we will now add one more thing here, which is the animator. And let's call it anim, and anim equals to get component animator. So now we have all the things that we need. So now let's create an update function. In the update function, what we want to do is, first of all, very first thing that we want to do is create a new variable. Sorry, float distance. And this distance is basically vector3 dot distance between our transform dot position, which is our position, like the agent's position, and the target's position. So basically, this is calculating the distance between the enemy and the player from the enemy's perspective. And then we will create a few conditions. So if distance is greater than 2, we'll add agent dot set destination. So this is a function in the agent. What is our agent? Is the navmesh agent. So set destination, and here we give target dot position. So if distance is greater than 2, we want to do this, and if not, and apart, like, also we want to start walking in this place. So what we'll do is nm dot set bool. The bool was is walking to, and nm dot set bool is attack false. So just because we'll be turning it on somewhere else, it's better to keep it as false over here. So next we have an else condition. If the distance is not greater than 2, which means the great distance is less than 2, which means the enemy was very near the player, then what we want to do is anim dot set bool. I'll just copy these things, I guess that'll be faster. So walking here would be false, and attacking here would be true. So, and one thing else, what we want to do here is this thing, which is agent dot update position. Oh, sorry, equals to false. So what this does is basically it is not going to move the agent anymore. So that is what we want. Once the player has reached a specific distance, once the agent has reached a specific distance, which is less than 2 from the player, it stops and starts attacking. And what we can do here, because we have turned this false here, we can just try and turn it again. Uh, agent dot position update position equals true. So now we can try and test it out and go back here. Everything is set. Let's see how this works. So our enemy is coming to us once and then attacking us, then not moving again. I think that's because we either messed up the animations, or one of the things that we also did not do was loop the animations. That's why it wasn't working properly. So we'll go to walking place and we'll turn on loop time and loop pose, and set an option to save this. Okay. Similarly for this, the attack thing, loop pose also is there, idle, loop pose. I think loop was on, so that is not an issue for us. Probably something else. The walk animation is not working, and the position animation is also. It's only taking the very first position, going there. Okay. Let's try once more what is happening. So basically what we can do is when we select the enemy zombie here, we'll be able to see what is happening in real time here. So quickly move to the other location. It is walking in place, then it is going to idle, and then it is going to attack. So for some reason, it is not um, navigating. Um, It set the agent auto braking radius. So anyway, I'll figure this out. I don't know what I've done wrong. Set destination is target dot position, and this distance is transform and set the player. I think we can try and debug here. So we can try to debug dot log the uh, distance first, and let's see, and then distance is greater than 2, which again should be updated. Then this thing should update, then this one should update, and walking should become false. Here walking is becoming true. So yeah, let's test it out again, and let's this time see what is coming in our console. So distance is greater than, okay, so that seems to be a problem, that our distance is not changing now. Once the enemy reaches there, the script does not seem to be working anymore for some reason. Yeah. uh, so it starts off with a distance of around 7, and then it's stuck because the player is this thing, and it's not updating the player position. So yeah, so that's what's happening. It is not updating the player position. Okay. And position.set position is basically not happening. So target is this thing. Then we can try, because the distance is not working, we can try uh, see if target position is changing or not, because that is how it's supposed to calculate the distance. So target position is our next debug. So that's the thing, I guess. The target position is not changing. It has become static. Somehow it has become static. So maybe we should not use this as player. This should be player. Is there any other thing which is tagged as player? No, let's try this once. So there was another thing that was tagged as player, but that would generally not be an issue. Yes, starts off well, but are we? This is where we are in our scene, but the target position is not updating, as we can see. So what we can do is try to change the target for the player and then debug. So if we bring in a cube, we tag this as player, we stop the player for now, and then let's see what happens. Is it working with the cube? So with the cube, it's working. So there's probably some problem with our player. So we can try to create a parent again. Try this thing. If this works, again, the target position is not updating. There's probably some issue with the starter asset that we have, that it does not update the position of the parent game object, I guess. We can try to see if we use this as player and this as untag. Does the position change now? that works. So I guess that's what's happening is basically, so maybe the player, sorry, this thing is set up in such a way that if you remember that we use these few different things here. So probably this is set up in such a way that when we use the player tag on the parent game object, it's not working. So now I can remove this from here. I don't need this one. But when I use it here, it's working. But is my animation looking good? Next point would be that the walking animation is not working, and this animation starts up a bit late. So now what we have to debug that. Although it is looking quite good, we can try to match the height of the player later, but this attack part is looking good. Now let's see what's the problem with the walking part. So it goes walking is working, but apparently this walking is not working. So instead of walking place, let's try the other walk in place. Shaka, we'll try this thing once and then let's see. Uh, keep this here. We'll have to delete these. And when walking is true, here when attacking is true, and again walking is true, when I don't think we need to do this. Yes, we can do walking is false. Let's see, quick setup if this works. So walk animations are not working for some reason, but the other things are working. So yeah, so this is something that I'll try to figure out. Maybe something wrong with the walk animations, and we can begin from here in the next session. But this is the beginning of how enemy AI is supposed to be. So we basically have a certain distance where the player is player and the enemy positions are checked, and based on that distance, we can use certain different animations. And when those animations are run, it'll seem like a state management is being created, which we are creating. We can also create a probabilistic state management, which is a bit advanced enemy. AI would be there, which we can talk about later. So I think that is where we stop today, because if we don't fix this, there's no point moving forward. So thank you for joining today. If there are any doubts, please ask.